Hi everyone, and I am Jawwad. So, welcome to today's session on nested virtualization. In the previous series, as you know, we learned the basic setup to create virtualization using VMware. We also installed VMware ESXi, DNSVM, and vCenter. It was just the glimpse of virtualization. In this series, we will be discussing about nested virtualization, which will include installing KVM, building bridges for lab, installing EVNG, and then we will set up the Cisco and Nokia routers, deploying the run machine also for the DevOps. So, what was happening before virtualization? If a company wanted to use different programs or service, then usually they had to get a separate computer for each one. Just imagine a room of full of computers where each one is running just one thing. It took up a lot of space and cost a lot of money. And it wasn't very smart in terms of resources. So the revolution of virtualization comes. So let's start. What is virtualization? It is about creating virtual versions of the something physical. This could be anything from servers that run our website to the storage devices where we can keep our data, even to the networks that connect everything together. By create Basically what we are doing, we are creating a virtual instances which make them independent on the hardware underneath. Basically what was happening before, we were running for each application different server, but now in one server you can run different application, different many operating system at the same time, so you are utilizing more. As I said, what's happening now is we are running multiple computers in one machine, and so you can think about the flexibility and the efficiency which it brings to our infrastructure. So what is the significance of the virtualization? It basically improved our resource visualization, increased flexibility and scalability, and also enhanced disaster recovery by backing up and restoring virtual environments. And it is very simpler as compared to before. And it is simpler management. Why? Because we are managing everything from a single console, while before there were so many servers, it is difficult to manage and deploy, or anything if you want to migrate. And also, it's energy efficient because you don't have to run separate server as before. So what are the types of virtualization? It's come in different flavors. For example, hardware virtualization, which most of the people think of when they hear virtualization. It's about creating virtual machines. Think like instances. You create a instance of object in object oriented programming from class. So it's something like that. You are and each one is isolated. You are creating a separate computer, and each separate computer is called a virtual machine, and it's totally isolated, and it has its own application. um, so this is one of the types of virtualization. Second one is software virtualization. We are emulating the computer system within a software, making applications run independently of their underlying platform. We didn't care what is the hardware, whatever it is. Thirdly, we have the storage virtualization. Imagine pulling together storage from multiple devices, like we did in the previous series. We make a cluster of the devices of the hard disk, which in the ESXi. So this is basically what help us in managing data and improve the recovery processes also. Then we have network virtualization, which is they merge the hardware and software resources into a single virtual network. What is actually it is? Its think is as a examples are many. Like we have vSwitch, we have OpenSwitch, and we have DSwitch also. And also in networking, you can see SD-WAN network where you have a controller, and similarly in the segment routing or in the MPLS traffic engineering, you can see you have a controller which has all the information of the network. Uh, so this is one of the types of virtualization. Lastly, we have desktop virtualization. Most of you have used a VDI for the remote access approach with a host desktop environment on a server, which help in deploying them to the users on demand. And it's also basically centralized the management and enhanced security and offers much flexibility in how and where users can access their desktops. Okay, so now let's come to the hypervisors. We already discussed about hypervisors before, but let's recap again. What are hypervisors actually? In a layman term, you can think you have a big party in a huge hall, and you are given a magical power to create invisible smaller room inside this hall. So inside this halls, in this big hall, uh, what you can do, you can you can create a smaller rooms inside that hall. Smaller rooms are these VM. Inside this each room, different groups of the people can have their own little parties. Those parties are the applications. Okay, without seeing or disturbing each other, means it's not disturbing each other, right? And they are enjoying themselves in their own space, even though they are technically in the same big hall, which is ESXi. So basically, in the world of computer, hypervisor does the same thing. Think of the computer as a big hall. It will be easy to understand the picture. And the invisible rooms are the separate virtual computer, which I already told. These are the virtual machines. And the hypervisor is the magical power that creates and manages the VMs. It makes sure that the virtual machine thinks it has its own computer with its own resources like memory and the power processing power, even though they are sharing on the same physical computer. This way, you can run different operating systems. So we have two type of hypervisors: Type 1 and Type 2. Type 1, you directly run the hypervisor software like ESXi or the Linux KVM, and then you create the VMs on top of it. But type of 2 hypervisors, mostly you have PC or laptop on which you have already Windows 10 running, and then you run the hypervisor, like you have VMware Workstation, VMware, and Oracle Player, and many. And then on top of it, you have VM. This C is representing is the container, uh, which usually run on the operating system, or it can need some kind of operating system definitely, like the VM should be running. So, but in this container, there is no need for having a separate operating system. So this is just for the clarity. What is the role of the hypervisor in the virtualization? They are the basically the backbone of the virtualization. They are like a conductor of an orchestra, ensuring that each plays part beautifully without any interference. So what it's doing is basically resource doing the resource allocation, and it's making isolation at the same time for each VM, and managing also. You can, with the help of the hypervisor, we can usually create, modify, and monitor the VMs. And portability also it provides by moving the VM from one place to another easily without any hurdle. I hope it is clear. Now let's come to the nested virtualization. So what is it? Actually, you have seen the toys which where our small doll is stuck inside a bigger doll, And then there is another even smaller one inside that. If you have not seen, you can see on the right hand side of the slide. In the world of computers, we have the same pretty thing. It's called nested virtualization. Imagine having a computer inside another computer and sometimes even one more layer deep. So it's like one box, bigger box inside another bigger box, inside another box, and then inside another box. So what actually makes uh, you special about this one? So is not just a regular computer stuff. Usually, when we use virtualization, we run the virtual machine straight on the computer. But nested virtualization adds basically a twist, as if you are putting a virtual computer inside another virtual computer. And guess what? We can use different type of software to run each layer. So, like having VMware running a virtual machine, and inside that machine, we are running another type, say KVM, to run more machine. It is just a good trick. It's open a ton of opportunities, and it can be helpful for training, testing, and um, playing around the technology. So you can see also this. We have the hardware. We can have any hardware, HP, Nokia, airframe, or Cisco UCS, and on top of it, you can see like we did it already in our. We installed the ESXi, and the ESXi will have separate VMs here, right? And then on top of it, I will install another VM which will be KVM. Okay, but this is the will be a VM for this hypervisor, but this will be hypervisor for these VMs. So this is how it is nested. You see, it's really fun. Now we go to the key virtual technologies which are mostly discussed. We have already discussed all of those, but let's discuss about again. KVM we will discuss in another video more, but we will just give the overview here. What are VMs? As we said that it is the first our journey um, toward virtualization. Imagine you have a box that I give you example before, a very special box that can mimic any computer in the world. Inside this box, you can run a whole computer system and complete with its own operating system and application, just like your physical computer. But here's the magic: the box is not real, it's just a virtual created by software. So that is how what is VM is. VM basically allow us to create several isolated environment on a single machine. And you can run Linux also in one virtual machine, in the other you can run Windows, in other CentOS. So isn't it pretty? And next we come to the KVM, which is kernel-based virtual machine. Uh, it's where the Linux shows its superpowers. KVM turns the Linux kernel itself to the Type 1 hypervisor. We will go further in this one. In the next video, we'll discuss completely on the KVM. Okay, let's discuss about the bridging network. Um, when you have running already your VMs, now you need to talk to each other, or the VM need to talk to the internet, right? So here the terms come bridging network. This is the bridging network in our digital work allows the VMs to connect to the network just if they are physically plugged in. Just like your laptop is physically plugged into the line, it will be also mimic the same thing, and VM will be able to communicate with the other machine on the network without the physical adapter needed. Uh, so this is of the beauty of the bridge networks. We will also discuss in details when we will be creating bridges in the KVM. Those bridges are same as we discussed the port groups in the ESXi in the series one. Okay, what is VMware ESXi? We already discussed that that it is the product of the VMware ESXi, and it's a wizard stuff in the world of virtual environment as compared to the KVM, which is mostly the CLI based. And it's a type 1 hypervisor, just like KVM. ESXi is renowned for its performance, stability, and extensive features from a resource management to the security enhancement. So this was the power full. As I told you, bridging network in the VMware universe is the same as the bridging network in the KVM. Think the port group as an exclusive club within the vSphere environment, and each club or the port group has its own rule and allow VMs to communicate based on those rules. And when you assign a VM to a port group, it's like giving a VM a membership card to that club, allowing it to communicate with others in the same club. You see, so it's like a template. These port groups are essential for organizing network traffic in the VMware environment. All right, we have already discussed port group in our previous sections. So now you can see here the diagram, how it's working. In our lab, this is the case which we'll be making. On below, we have HP, it could be any hardware server, and on top of it, we are running hypervisor. And on that, we run the uh, this vCenter switch, which is what basically this that is the network bridge. This is the network bridge, okay? And on top of it, we have port group. As I told you, it is also a bridge. And this bridge, it's called bridge in the Linux world. The functionality is almost the same. So in this port group, we will assign the VLANs. For example, it will be assigned to specific VLAN 10, and that VLANs can easily communicate on that. So you can see we will install another, because it's a nested virtualization. We are installing another VM, which is KVM, and it's for these VM it is acting as a hypervisor. But actually, this for this VM, this is the hypervisor, right? Why is sorry, this is why. All right. So this VM, if want to communicate with this VM, it can easily go to here. But if you want to communicate with this VM, it can also go. What will happen internally? This when we will create this VM, we will assign some kind of port group to it, right? Because this VM is running where? It's running on this hypervisor ESXi. So this traffic will go from here to here. This is you can create bond, which we'll see. Um, uh, you can aggregate the traffic, or you can make active standby, or you can even isolate traffic. So from here it will go to here port group, and from there from this bridge or switch it will go to this VM as desired. You can see this bridge is assigned only for this VM3, and this bridge cannot talk to this bridge because this is another subnet. It is another subnet, but it can talk if you have another VM running here as a controller, which is a router. Then it can talk. And you can see here the physical interface. For example, if this VM need to talk to the internet or to some external devices, it will go from this hypervisor, will go to the port group, and this port group definitely will go to the D switch, which is have the uplinks, and those uplinks are mapped to the physical NIC, and then thus it will go to the internet. So this is how the the nested virtualization will work. But don't worry, we will see all this live in our lab demonstration from scratch if you still it is not clear. Now, definitely there are benefits of nested, but virtualization. Also, there are some disadvantages. So, what is the good stuff? It's being super flexible, and it can grow or shrink as you need. And testing is really easy. You can make any as your lab as you like, and it's keeping things safe and separate. What is the bad thing is really slow down because you are adding up the layers, and it can be really complicated to set up the lab. But don't worry, we will go through it. And so this is, um, and the last thing is keeping things safe and separate because of, uh, the thing is separate plays areas of your different games or projects. If you something goes wrong in one area, it didn't uh, mess up everything else. So this is the keeping things and separate. But when we talk about extra safe, is great for every new layer is like adding another lock to the door. So it's great for security, but it's also mean that one more place of potential sneaky stuff to happen. So we need to be extra careful. Although this also it has an advantage, but it has also at the same time have some disadvantage also. So these are the use cases which we can see. You are basically building your um, own sandbox. You can imagine like you are a builder and you can create, demolish, and rebuild house anytime you like without any mess. And you can also use for educational purpose, which I am using. I am need to play a lot of practice for my own learning, and also you can make for simulation environment, and whatever you want to do, um, you can set up your lab as per your needed. You can mimic what is your requirement. So in the next video we will discuss about the architecture of kvm and the installation on the VMware ESXi using vCenter. And really thank you for watching this video. Hope you like it.